Hey everybody, this is Mr. Grabo. We're going to continue on with chemistry and we're going to dive into the topic of covalent bonding. So far we've talked about a different kind of bonding called ionic bonding, and that's when you have metals and nonmetals binding together due to their opposite charges, and those opposite charges attract. Today, covalent bonding is a little bit differently. This is a little bit different where they're sharing electrons. If you notice in the picture here, we got two dogs that each have a bone. And after fighting over it, they end up sharing the pair of bones, similar to what's going to happen in covalent bonding. Okay, let's take a look at the right side of our notes where it says bonding review. First thing we want to do is we want to look at group 7. Group 7 is right here, and everything in group 7 has got 7 outer electrons. Now we know that it wants to get to a stable 8, so is it going to be easier to lose 7 electrons, or is it going to be easier to gain 1 electron? Well, when you think about it, which one's going to take more energy? Okay, it's going to be a lot easier to gain 1 electron rather than lose 7. If we look at group 2, which is easier? These all have 2 outer electrons. We can either lose 2 electrons or gain 6 electrons. Well, it's going to be much more energy efficient if we just lose 2. And what about group 4? In group 4, they all have 4 outer electrons. What's going to be easier, to gain 4 electrons or lose 4 electrons? Well, that's kind of where we are not really sure. It's not really energy efficient to do either. So let's take a look at what could happen. So it is unlikely for some elements to lose or gain electrons. Some of these are not going to want to do either because it takes a lot of energy to transfer that many electrons. So for example, the elements in groups 4 and 5 of the periodic table, they have a hard time transferring electrons. The transfer of this many electrons takes a great deal of energy. And they're always going to do what is more energy efficient. Okay, so what's the story with these? What are we going to do with some of those that don't want to transfer electrons? How are they going to bind with something else? Okay, so therefore, these atoms in group 4 and 5, they become chemically stable by sharing electrons. So they don't lose electrons or gain electrons, they share them. Most of these elements where this occurs is non-metals. Okay, on the right side, what do electrons do in ionic bonds? Do we remember what happens with those? So here's an animation of 2 hydrogen atoms that are bonding together. They each have 1 outer electron, and together, when they combine, they're sharing those 2 electrons. So it's kind of like the dogs in the first picture that I showed you of they each had a bone, and when they put them together, they each had 2 bones, but they were sharing them. Here we got 2 atoms that each has 1 electron, but when they combine together, now they each have 2. So covalent bonds are formed from an attraction between atoms when they share electrons. Okay, we got atoms that share electrons, and that's what's holding them together. They're each tugging on the electrons of the other one, and together they share, and they stay put, and they bond together, and they hold themselves together. Okay, electrons in a covalent bond, what we get here is we get the neutral particle that forms as a result of electron sharing. It's called a molecule. Okay, so carbon dioxide, water, sugar, all examples of bonds that are covalently made. Okay, so who's doing the sharing here? Covalent bonds typically form between nonmetals. This is the opposite of what was happening in ionic bonds. We had metals forming with nonmetals. Opposites attract. Here it's a little bit different. We got nonmetals that are forming an attraction because they're sharing electrons. And so you can even have two nonmetals of the exact same element form together. So they can even form between two atoms of the same element. So we can have two fluorines form together, two nitrogens, chlorine, bromine, hydrogen, lots of examples. So when there's two bonded that are the same, we call that diatomic. The first part of that word, di, di means two, atomic means atom, and so it means two atoms. So take note of a couple of those diatomic molecules on the right side of your paper. So chlorine is an example of how atoms can bind with themselves. They can make a diatomic element. So let's watch and see how chlorine does it.
Two chlorine atoms will react with one another to form a chlorine molecule. Why and how does this reaction take place? Each chlorine atom contains 7 electrons in its outer energy level. To form a stable octet, the two atoms have to share a pair of electrons. A covalent bond forms in the resulting chlorine molecule. The shared pair of electrons moves around both atoms.
Okay, one more thing we want to talk about before we get into the problems is this kind of exception to the rule. Hydrogen is very, very small. Hydrogen's the smallest atom. So hydrogen can be stable with only 2 outer electrons. This works because hydrogen only has 1 energy level and if you remember, the first energy level only holds 2 electrons, not 8, but 2. So if you look at the picture on the right, this is hydrogen. It's got 1 outer electron. What it wants to do is it wants to gain 1 more electron to become full, because the first shell only holds 2. So hydrogen's that example where it only needs 2 to become full. The rest of them that we look at need 8 to fill their shell. Okay, so these are the steps to show covalent bonding. So on the left side, you're going to take the directions down, and on the right side, we're going to actually do the model of the covalent bond. So step 1, write the symbols for each element. Okay, in this one, we're going to do hydrogen. Hydrogen is already on your sheet. So we're going to do the symbols, which is H. Draw the Lewis dot diagram for each element. Well, if I look at my periodic table, I can see that hydrogen is in group number 1. So I'm going to make just 1 outer electron, 1 covalent electron. I'd like to use different colors so I can tell which hydrogen is which. Okay, that's step 1 and 2. Easy peasy. Next, redraw the symbols. So you want to copy this in. Redraw the symbols. Move the single electron between the elements to show that the electrons are being shared between the 2 elements. Okay, so what I'm going to do is I'm going to draw my hydrogen with the dot on this side. I'm going to put my other hydrogen right next to it. And that one was a red. Okay, so I'm just drawing them so the two electrons that are being shared are right next to each other. Step 4, draw circles to show the sharing of electrons. So here I'm going to want to draw a circle showing that hydrogen is happy. So it's got one of its own and one of the other hydrogen's electrons. I'm going to show that this one is also happy. This one's also got 2. Remember that with hydrogen, it's that exception to the rule. It only needs 2 electrons to fill its outer shell. Okay? The next step, we're going to draw the bond structure using symbols and lines. Use one line for each pair of electrons that is shared. Okay, so I'm just going to redraw this. Okay, so to replace this pair of electrons, I just replace it with a stick or a dash. And that represents a pair of shared electrons. Step number 6 is write the chemical formula for the new molecule. Well, the new molecule that we've created is H combined with H, or H2, 2 hydrogens. It's a diatomic element. Okay, so here's those steps again. Step 1, we write the chemical symbol, H. Step 2, we put in our Lewis dots. Step 3, we put them next to each other so we can see where they're going to share. And then step 4 is to draw the circles around them, showing that they each now have a full outer electron shell. Step 5 is to replace the shared electrons with a stick or a dash. Step 6 is to say what the final formula is. Okay, let's try another example. Let's do an example with 2 hydrogens and 1 oxygen. Okay, so first what we're going to do is we're going to put our element symbols. I'm actually going to do 2 hydrogens because the problem says we have 2 hydrogens and 1 oxygen. Okay, so we draw the Lewis dot structure. Hydrogen is in group 1. Oxygen is in group 6. Okay, now what we want to do next is we want to arrange the elements and electrons to show sharing. So I can see that these 2 hydrogens with 1 electron, they're going to want to go here. They're going to want to get to those empty spots on the oxygen. So I'm going to start with my bigger one. I'm just going to start with my oxygen. And then I'm going to rearrange it so my hydrogens are right next to where they want to be. So I'm going to put my hydrogen here with its 1 electron, and another hydrogen here with its electron, and then I need to show the circles. So this hydrogen is happy. This hydrogen is happy. Remember, they only need 2. Oxygen is like most others. It needs 8. So we draw the circle around oxygen. It's got 2, 4, 6, 8 electrons. Last 2 steps, the stick structure and the chemical formula. So the stick structure, all I need to do is replace this shared electrons with a stick. So here's oxygen, hydrogen, hydrogen. chemical formula. I'm just going to add them up. We got H2O, water. Okay, so let's kind of wrap this up with a summary. Covalent molecules, elements that covalently bond, share electrons. This occurs because both elements want to gain electrons. By sharing electrons, both elements can get a full outer shell of electrons. This occurs with two or more non-metals. Okay, let's just quick compare this to ionic bonds on the right side of your paper. If you remember ionic bonds, they transfer electrons. One element gains electrons and one element loses electrons. And remember, this happens between metals and nonmetals. Opposites attract. Okay, go on to the practice problems and let your teacher know if you have any questions.